I've got one here. I feel Pat's good.
And it's a mom. It's not even a kid.
Oh, that's all right. You
But
know what?
he's gonna be joining soon, I think.
Oh, that's fine. That's fine. I think we got about 7, 8 minutes in there. Any questions you got ahead of time that you want to ask?
Um, I guess. Well, I know that I know nothing about what you
Okay.
do.
All right. Well, that's all right. That's fine. We'll do an education round tonight. Matter of fact,
Good.
the I can kind of relate to this in a unique mode. About 47 years ago, I walked into open house, and needless to say, my mom didn't know anything at all about it either.
Well,
So I can truly relate to that one. Now the catch was my dad understood it, but he wasn't a toolmaker or machinist, but his brother was, and so he knew that background. Okay.
well,
Um,
that's good.
and so it was kind of like my mom come in and she was like, "Oh, you got to be kidding me." She saw all this equipment, whatever, but she was familiar with it in a way because she was a chief of transportation at the ammo plant at Charlestown for the Army Materials Command. And so, she was around large manufacturing facilities, and they had full machine shops and this and that. And so, she knew you know, it wasn't like she was a school teacher or how should I say, a daycare worker or, she was actually in the environment that in the manufacturing world.
Ah, okay,
That,
I
that,
see.
that helped a little bit. It wasn't like she was a nurse or a dental hygienist or anything. So
Right.
so that made a difference there a little bit. And she was very familiar with skilled trades on that end. So that helped out a lot. That was good. But that works. The little background: this program's been around since day one here at Prosser. Uh, I feel like I'm almost a day one, but I'm not. I'm actually the longest employee and actually the longest time at Prosser. I was 2 years as a student, and I started my 36th year of teaching about 2 weeks ago. Actually, about a week ago.
Oh,
The
wow.
14th, yeah. So I started mid-year. So and I have been in the shops on the precision machining side for the last 26 of those years.
Oh,
So
wow.
it's kind of interesting. It's been good. Can't complain a bit. So I get up and go to work every morning, and I'm happy.
That's a good thing.
That's the nice part. Little background: we are actually an early college program, so I'll give you that heads up on that. We are actually partnered with Vincennes University, and Vincennes has a dual partnership with Purdue University. So, and I don't know whether you said, I don't know if it's a son or daughter that's looking at
Oh,
the class.
it's
What?
my son that's
Okay.
interested.
Uh, with that in mind, we have some pretty neat deals here from the point of view, and I can show you and give you a breakdown on it for school and continuing education. When you get out of high school, you got 2 or 3 different options in there. It used to be basically two. You either went to work in industry or you went to college.
Mm-hmm.
And usually, if you went to college, that cost a lot of money.
Right.
I've got a way for your son to go to college for a year for free and actually give him money while he goes.
Well, that sounds pretty good.
We actually have a scholarship fund that I get to choose on, and the Gene Haas Foundation, which is Haas CNC Machinery, and I'll actually roll this table I'm sitting at. I'm not sitting at my desk, okay? I'm actually kind of sitting on the shop floor in the evening. The custodians have got all the chairs up and everything else out here. And I'll roll the table out with the Chromebook in there, and I'll actually take you on a little tour of the shop.
Oh, okay.
So we'll do that one. But the Haas Foundation, the Haas CNC is the largest producer of CNC equipment in the world, and for machining. And that CNC stands for computer numerical control. So instead of manually turning all the knobs and cranks to make what you need to do, you program everything. Okay, so you're using a computer to do that, and we teach students how to do that. But we've got several Haas machines here, and they have a fantastic partnership. They actually allow us to. Oh, I see another one here. This must be your son.
Oh, could be.
Same name, Juan.
Oh, yep, that's my boy.
All right, sounds good.
Hey, bub.
But the CNC program here, Haas actually has given, this past year was another $12,000. So they've given us up right now $49,000 total over the last about 3 years, and I get to give up to a maximum of $2,500 a year for a student if they continue their education going to like Vincennes or going into advanced manufacturing. So if they go precision machining or advanced manufacturing, either way, I can give them a $2,500 scholarship. But actually, we write the check, and it actually goes to wherever they're going to school at, and it goes right into their account. So they can't just take the money out, cash it, and skip out.
Can't just go on
there's
vacation
some of them
with
that wanted to try that over the years. But the interesting part is, if you go down to school, and let's just say if you go to Vincennes or wherever for machining in there, or you go out in industry, one of the first things you got to do is buy tools, and tools are expensive. I'm going to tell you up front. And tools are about, depending on how you do it, about $2,500 to $3,500, depending on what brands you buy and how much you buy when you first start. Well, here's the catch. I can give them that money. It goes into their account, and in essence, the school actually orders their tools, and they have it there when they walk in the door, and they actually have all their tools paid for, basically. And I'll tell you about the scholarship end. It's kind of neat. Depending on the student, how much they apply themselves, they can actually earn up to about a year of college while still in high school. Okay. So if they earn 1 year when they walked in the door, and they spent, they spend 2 years here, and they can earn a year of college. And then from there, they literally can take the second year and go down to Vincennes. With workforce development right now in the state of Indiana, it's rather interesting. They have there's a shortage of tool makers, machinists, mode makers, all in the precision machining field. They're actually paying, if a student has got a 2.5 GPA, they'll pay half of their room and board. If they have a 3.0 GPA at their home school, which is a B average, they'll pay 100% of their room and board. And the other half is, for either one of those, their entire tuition is free. So I'm talking about, you're able to go to Vincennes the second year, and if you got a 3.0 at your home school, your room and board and your tuition is free right now. I've got about a total of 6 or 7 kids down there right now, some in first year, some in second year. And so it's their first year down there. And they didn't have the opportunity to earn 2 full years or a full year of college. They didn't pick up their electives while in high school for their math class or English class that you got to take. And it's a class in there. So because of that, they're going to be there a little bit more than that 1 year in there, but they can pick it up. And Vincennes has a really neat deal. You can do your third year of college in basically 15 weeks. And when you graduate with your associates in May, they go from May to August, and they're up there and they go 8 hours a day, 5 days a week, just like a job. And they spend their third year, and in that 16 weeks is their entire third year of college done. and it's 100% on between working on the computer systems and on the computer lathes and mills out on the shop. And so they have their third year of college done. And the interesting part is they can go to business and industry afterwards, walk right out the door. They got their third year of college done. Their fourth year, they can do it 100% online. And wherever they're working at usually always pays all their fourth year of college. So they now have a bachelor's of science in technology from Vincennes, or some of them stay on campus and they actually go under the Purdue elective because Purdue has a program on Vincennes campus, and they finish up and they walk out with either a bachelor's in mechanical engineering technology, industrial engineering technology, or organizational leadership and supervision. So they have a way to earn all their college basically and walk out the door with a bachelor's option in there if they want to continue. You know, some kids just want to go get their associates and work in the shops. I really encourage everybody to do the third year, but because it's only 16 weeks, 15, 16 weeks long, and you have your entire third year done. And once you have that done, you have the opportunity to say, I'm not real motivated right now, and I maybe only want to take one class a semester, but you're working and the business is paying for it, and you actually do it online, and you can still wind up getting your bachelor's and somebody else is paying for all your college. I like that approach, okay? I actually got out of high school, did not think I was ever going to go to college, went to work for a little company called General Electric in the Applied Research and Design Center as an equipment developer in the research labs. And GE sent me for my apprenticeship. And so they paid all my college. And I graduated and got caught in a layoff. And I had my associates done. And because I got caught in a layoff, they had a golden parachute because we were salaried, and they sent me back for my bachelor's at Purdue, and I finished up my bachelor's degree, and they paid for all of it. And it was kind of nice to let somebody else pay for my college. My parents didn't have to worry about that, and that made them happy too. And I see I have somebody else in here. I got a Matthew Trowbridge. Is that right? Can you hear me, Matthew? All right. Oh, okay. Yes, and they're good. Now, I went to school with the Tony Trowbridge. He was a classmate of mine at New Albany. We were on the soccer team together, state championship team back at New Albany years ago. So I don't know, maybe Tony's a relative on that. But now it's about 6:05. So let me start off. Which way do you all guys want to go and ask questions in here? I can do a little introduction, a little background. I was actually talking to, it's Jessica, right?
Yes.
Okay.
Yes.
I'm talking to Jessica, and I got Juan here, and I got Matthew here. They said to start at 6 and finish at 6:30. Make sure I stop. I'm long-winded at times. Okay. Welcome to the Precision Machining Program. It is a 2-year program here at Prosser. When we get done, students are able to do 2 or 3 different options. They can go into industry and work immediately. They can go for an apprenticeship program in industry. They have the opportunity to go to college. We have a partnership with Vincennes. Actually, this shop, kind of interesting. I don't know if you've ever been in it before. This shop we just put in last year $500,000 in brand new equipment. As we have the partnership with Vincennes University. Actually, Vincennes bought it. They actually bought it for our shop. There's about 2 or 3 early college sites in the state that are partnered with them, and we send them a lot of students over the years. Very successful on the program and they actually invested back into the school here. And they've spent more money in this department than they've spent in any early college program in the state. So that kind of says we've got a really good deal, a great partnership in there, which is nice. And they support us, we support them, faculty and staff. I'm actually in the faculty for Vincennes University besides. I taught for Purdue as an adjunct for 15 years in the mechanical engineering technology programs. So kind of give you a little background. I'm a journeyman toolmaker, and I'm a certified manufacturing engineer, and I have a degree in mechanical, an associate and a bachelor's in mechanical engineering technology, and a bachelor's in business and industry. It's actually trade and industry for vocational training. And my end I was trained on the corporate side. Okay, so literally to do corporate training for manufacturing, basically, was my background. And so I wound up in education kind of as a fluke. I hadn't really planned on that. I did my master's here. Okay, I actually was working in industry, and I actually came back, and once I went to work here, that's when I went and did my master's. Okay, but besides that, I was basically working as an engineer in the machining manufacturing world. So that's my background, and I'm a former Prosser student. I came here in 1974 and graduated in 76. And then I came back to work here in January of 85. And so I've been here ever since. Background, I kind of spent it literally, I don't know if you guys can see. Probably it doesn't come in good on the screen. I'll give you an idea. Behind me is a Mass Clever touch board. So I'll give you an idea of physical size. This thing is literally, I have the ability to PowerPoint and present everything across the board to students out here. We got a regular classroom with the whiteboards in the back, standard classroom environment, spin it around. Sitting right here, I'll give you an idea. Competition. Everybody likes competition. Everybody likes to win. Okay, and around here we kind of have a record. We have there's a competition for high school in precision machining, and it's what's called Skills USA, which is an organization that competes between all the high schools in the country that have career technical ed programs. We've actually had 3 winners at the national level. We've had a silver and 2 bronze, or I have over the last 25 years in the shop, 26. And we've got, I don't know, probably 35 state champions individually over that period of time. We actually have the opportunity to compete in about 4 categories. One is precision machining, which is basically all the manual machines in the shop. One is in CNC turning, which is a computer-controlled lathe. All the parts are turned at a round. We have one in computer milling. And then we also have one that's called technician, which is actually the ability to program and set up both in lathe and in mill. Okay. So we actually have 4 categories in there that we can compete in. So that helps. Sitting right here behind us, we actually have a second category in there, a second contest. The state of Indiana, the National Tooling and Machining Association, is throughout the United States. The chapter from the state of Indiana literally sponsors a state contest each year. And first place winner walks away with about $5,000, and they pay for the school. They pay for all their tooling, awards, scholarships. And right now we have the traveling trophy because one of my juniors, of all things, won the state championship this past year. We're going back, we're hoping to go back if COVID allows and compete this year on the state level. Or again, he wants to win this trophy a second time because he likes dollars and money. And so he said, if I can win another $5,000 while I'm in high school, that's kind of great. I was lucky enough that I was on a state championship ball team in high school playing soccer. And needless to say, they didn't give us $5,000. I wish they had. It would be nice. But that's a traveling trophy. We actually have, we've actually won this one particular trophy 3 times in probably the last 10 years or so. So it's kind of nice on that on rotation. individually. And we've actually won the team trophy on precision machining in competition there, to where all the kids walked out with the awards on that. So we've had a lot of fun. The kids like to compete. If, you know, some kids are really good, but they're not interested as a competitor on the shop floor. And they actually, it's a combination of hands-on and written and blueprint, and it's an all-day event. Literally, we'll go up and they'll start at about 8:30 in the morning, and they'll actually go to about 4 or 5 o'clock in the afternoon. The Skills Olympics are like that. We usually have a regional contest, a state contest, and then we go to the Nationals. The Nationals is scheduled in Atlanta this year. The state of Indiana did not run a regional. We ran a contest here just this the other day. Our kids are taking a bye to the state, and we're going to run a state contest. They're going to do it virtually for safety reasons. In each school, the students will be out on the machines in the shop out here. For the kids that are competing, everything's going to be emailed to them at a given time. The blueprints, they walk on the shop floor, they make their part, and then their part is, it's all being filmed and broadcast. And then from there, that is sent off as a package, and it will be judged with everybody else's across the state of Indiana to determine the state champions this year. A whole new world. We did not get to do, we had no virtual contests last year. We wished we had, but nobody was up to it electronically at the time to do it. But this year it's definitely different. Yes, we can. A lot of people ask, what do we do and what to expect and what do I need to know ahead of time when I walk in the door? Positive attitude probably is, and be here and be on time is probably the biggest thing. From there, the assumption is you don't know anything. Okay, my perception is I'm going to take every kid that, hey, they've never ran a lathe, they've never ran a mill, they've never ran a surface grinder, they've never programmed, and when you walk out the door at the end of 2 years, you can walk into any machine and walk up to it and operate it and run and be successful at it. Okay, from the point of view that either you can be employed in industry, or two, you have the skill set to continue on to finish up and earn a degree, whether it be an associate degree or a bachelor's degree. So it's a lot of opportunities there. I've got students, former students that went through that are everything from a journeyman tool maker to a mold maker to that went back and did an associate. Some have done bachelor's degrees. I have a half a dozen that all have master's degrees. So it varies, and multiple schools. Some are Purdue grads, some are U of L speed schools, some are University of Cincinnati, University of Evansville. So it just varies. They all depend on, it's where they want to go to school at, or in some cases their families have moved and they relocated, so they finished their degrees somewhere else. I got several kids that swore to me they'd never go to college a day in their life, and they're the ones with the master's degrees now. So it's kind of interesting on that. We start out with teaching them all the basics of how the machines work, and we usually do it by projects. Okay. In some cases, it's not the project itself isn't what's essential at making the end product. It is all the things that you have to learn to make the project and assemble it. Here's a prime example. Here's a vise. All right. All this starts out as raw material, every single item. The screw, the square, this is 12-foot long pieces of steel. And they're just raw steel out there. We'll take a look on the steel racks in there. And all this is going to be sitting on the rack, and the students learn how to run the saws, to operate them, to cut the material. They learn how to set them up in a machine, how to make all the cuts, all the calculations, how to totally make this 100%, and then how to put it all together and assemble it. So we'll actually take you from having never done any of this to an end product like this. And the vise gives us an example on that. I'm actually just going to spin some things around. Let me grab a couple things here. Um, all right. I'm grabbing toolboxes and parts here. I'll show you some projects in here. And then, all right, some of them are literally machine jacks that we use. They'll actually use them in industry. They put them in their toolboxes. They'll use them for the rest of their lives. I'm still using mine that I made in 1974, the 74-75 school year. So it's been a while. That's a large or a small one. This is the same category. It's a vise. It's a larger one. And this started out as a 12-foot rod, just a round rod. And when it got done, they did everything. They cut the threads. They made the parts. They bored it out. They actually made an extension that fits on top of it. And they made the swivel. And I've got this one is one I can disassemble and show them all the component parts, how they go together. And this fits on top and locks in. But that is one of the items. In doing so, you basically do all the operations that's required to learn how to operate a lathe on the shop floor. And whether you're making this, it could be a drive shaft. It could be a part for just about anything in industry. Think of anything round. Some people might say a flagpole, or you don't make that many flagpoles and selling them. Component parts in a dishwasher, a washing machine, automotive industry, aviation. Locally, we have a lot of companies that a lot of people don't realize do a lot of parts for aviation. We have several companies local that do parts for NASA. We do SpaceX. I've got students doing titanium parts for Mars, lunar rovers category, and parts for the new space rockets. You just watched the astronauts recently go up. Well, I got twin brothers in Louisville that are Jason and Justin are knocking parts out for SpaceX out left and right that are very specialized. We have people it was MedVenture, it's now Friedenberg Corporation, and they do a lot of stuff for medical. We have companies that are locally doing medical stuff for like stents in your heart, pacemaker parts. There's just a mass variety. Anything you can think of, automotive, very common on that end. The appliance industry with General Electric. Those are just a few. I mean, we have people in oil exploration. We have people in just various manufacturing firms all across Metro Louisville. And we have the big thing right now, we have a shortage of people and workers on that. So possibility, here's a V-block. Here's a student-made part. Top half goes with it. It has the ability to use and clamp and hold down this way. It can be turned over, and the part goes in there. This part here, when it's ground, this is literally all within 1/1000th of an inch. To translate 1/1000th of an inch, take a strand of hair on your head, and basically, depending on whether you got thick hair or thin hair, it's either going to be 3 or 4/1000ths, 4 slices in two. Okay, so it's going to either be 3 strands or 4 strands in thickness, very thin. So if you got fine hair, figure 3/1000ths, and that's how fine one hair is. And we actually take it down to 1/1000th. We have the ability on some aspects in here to actually go to a 10/1000th. That'd be take a strand of hair and divide it in 30 slices. So we can get very, 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 very accurate, and it's actually pretty easy on that. Actually, see another one in here. I see a Noah Jungla, and I had a Jungla last year that graduated. It's in the Navy. He was an excellent.
Yeah, he's my brother.
Is he? Oh, okay. Oh, that's great. Yeah, he's good. I hope he's doing well. Yeah, I know he was. He's getting ready to graduate, isn't he, or has he already graduated?
He's taking his final test in a couple of days.
Okay, well, that's good. I hope he does well on that. He was a good kid, man. I liked him. That's great. But so yeah, there's some neat opportunities. Actually, in the last year, we really your brother walked out the door while all the construction was going on, and we lived through dust and dirt for 2 years, 3 years, and now all of a sudden it's all nice, neat, and clean. You'll have to tell him to come back in and visit when he gets back home. Big time on that. But yeah, there's a lot of parts in here. Let me spin it around. Right now we have behind me is computer trainers. We actually have 16 brand new trainers in-house for programming that the students can actually work on. This is the exact same screen that they're going to see on a machine out there in the shop. As a matter of fact, what I'm going to do is I'm going to unplug this, roll it out of here. I know I'm kind of short on time. We got a 6:30 slot in here. They said we're supposed to be done by, but we'll go. One of the other ones here last year was, and I don't know. Let's see. I don't know if you saw it or not. When you came in, but one of the boys last year, it was a junior, won the programming for the whole state and for CNC. Let me roll out here. We're going to go out on the shop floor and hit this. Actually, I'll bring this down right here. I'll show you an interesting piece. They just rolled it in out of construction. They were pulling this back out and found all my stuff for me. Here is literally, let me see if I can get it. I'm going to go down a little lower. Here's a manufactured machine. This is a couple of my former students are all at Vincennes. And if you take a look, it slides back and forth. I'll show you the side view. Okay. Now, this goes up and down. It's all air operated. We don't have the pneumatics hooked up. This is back, left, and right. This is actually a pneumatic robot. Okay. So if we add the air hoses to it and we add what's called a PLC, a programmable logic controller, then you now can literally operate and have a robot. We can put what's called an end effector on it, on the part that slides back and forth, left and right. And guess what? That could be like a gripper, like your hand, or a pincher. It could be an air tool that runs a screwdriver, gets the end and spins for manufacturing and assembly. So this is a couple of the former students actually made these. They made them as a project up at Vincennes in there, and they actually sent one back to me. So I've got a whole series of parts here that students have made and done. Actually, we'll walk out and I'll give you an idea. Here's a couple of newest machines sitting right here. These are all, as you can see, it's the same computer control that's sitting in the classroom, and we have the ability to actually set up program, and these are 4-axis, so it means the machine will move left and right, in and out, and up and down. That's 3, X, Y, and Z. We also have a 4th axis that sits on the end that we can put a part in round, and it can rotate while it's moving left, right, back and forth, or up and down. So it's 4-axis machining. That's an option we have on a couple of new machines that's just been added. Each of these machines literally list for about $85,000 a piece without tooling on them. I'll give you an idea. So when you wind up in a math class or an English class, you know, you got a textbook and a couple of dollars, you got maybe a $100 textbook at the max in there. And here, and that's all you touch. And here you're going to walk in. As we look around the shop today, you're going to find literally $500,000 in brand new equipment, okay, plus the opportunity of some of the other equipment we already had in here. This shop combined probably has with tooling, with all the precision measuring with it, probably about $1.5 million in equipment. Okay, it give you a little bit of an idea of what's out there. The one behind me is literally, I'm going to kind of just go this way, it's a computer controlled mill. Let me just bring something up. I'm just going to bring something up on the screen. It has the ability, and I'm just going to load something. So, oh, that's Coast. Okay, I don't know what it is. There you go. And I'll bring it up close. It's got a part in here programmed, and we can actually run this part graphically without ever doing anything else. And before we ever start, it's getting ready to start here. And you'll see it blue. It comes up and goes around the part. The student can actually write the program, and I got to tell you, you probably can't see that. I don't know. Okay. Try and look at the screen here back and forth is you can see the pocket going around, the cutter moving. We can actually see it before we ever cut it. We know what we're going to do and what's going to happen in here, so we have less of a chance making an error. Okay. And from there, it's going to go around. It's going to do engraving. It's going to cut a pocket out up here. It's moving in this section. And it's actually going around and making multiple cuts and going down deeper, cuts more out, goes down deeper again. You'll do that on a couple passes. It's going to come around and do a pocket here and machine out a circle and then go in about a 1/2 inch down. And then it's going to go in and put a bow toe pattern and drill it in there. We used to be able to make this part manually would be about, probably 10 hours. On a manual machine. I got a student that can write this program, cut it out, and have it cut in about 1 hour, 1 hour and 15 minutes. That gives you an idea a little bit difference with the computer controls on it. And so from there, as I spin around in the shop, you can kind of see there's another mill right here. This is one we were just working on and doing. And there's a part here that was made that's it's a Prosser logo. And it's all machined. It actually takes the machine here about 20 minutes total to cut that out. But it's got printed out on a sheet of paper, it's got probably 150 pages of code. It's actually all generated. They take a picture and they run it through a piece of software, and the software converts it to machine code in a language that the cutters understand and move to cut that out. And allows them to make the part right there. So that gives you an idea. Right here is another mill, and sitting on the end down here is 2 computer controlled lathes. And right now we're kind of working on a little project in here that we want to do, that the students are going to look at making chess sets. So they're going to learn how to program all the component parts to put in here, and we've got the material, so we're looking at programming and learning how to do all the moves to make chess pieces. That way they got something when they're done. It's a neat project. They may play chess. Somebody that doesn't play chess, hey, we may make the same thing and actually make it out of a checker set. Little piece, and we can actually anodize it, and which will change the color. And so we can take the aluminum and make it various colors through an anodization process.